Okay, this video is going to be covering exponents. We will go over several different types of problems. We will use the product and quotient rules with your exponents. We will also use the zero and negative exponent rules. We will also look at the power rule. We will find the power of a product and a quotient, and we will also simplify exponential expressions, okay? So first things first, let's talk a little bit about what we're doing when we have exponents, okay? So if you see something like 2 plus 2 plus 2 plus 2 plus 2, we know that's the same thing as 2 times 5. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10. All you're doing is repeatedly adding, basically. So we kind of shorten that up with multiplication and say, okay, 2 times 5. We did it 5 times, okay? So we're doing some repeated addition when we do multiplication, okay? When it comes to exponents, we're doing repeated multiplication, okay? So it's things like 2 times 2 times 2. Well, we know that can be written a lot shorter as 2 cubed or 2 to the third power. Here is a very long list of 5. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that is 5 to the 16th power. Obviously a very large number because, again, it's repeated multiplication of 5 times 5 times 5 times 5, okay? So understand that when we're doing exponents, that is how we communicate repeated multiplication. So you have some sort of a base, and then you have a power that tells you basically how many times are you multiplying that. So 8 is your base in this one, while 9 is your exponent. Okay. So something like this, 5 to the second power, we would read typically as 5 squared. 5 to the third power, we usually say, oh, 5 cubed. After that, we kind of quit having special names for them. 5 squared, 5 cubed. Then we just have to say, oh, this is 5 to the fourth power. And like I kind of originally said, 5 to the fourth is a shorter way. Usually you can say power, but you don't. We usually understand what you mean. And last but not least, this is 5 to the 12th power. I'm trying to fit it all in there. 5 to the 12th power. A lot of times just say 5 to the 12th. Need to write neater. Okay. So we're going to take a minute or so and just rewrite these three in exponential form. So 5 times 5 times 5 times 5 would be 5 to the fourth. 4, I just count them probably 1, 2, 3, 4, 5, 6 would be 4 to the sixth. 1, 2, 3, 4, 5, 6, 7, 8. So 3 halves to the 8th power. So we have a fractional base there. You could break that up and you could say or 3 to the 8th over 2 to the 8th. Okay, so probably a little shorter doing that just because you don't have to write the 8 twice. But either one is acceptable, okay? All right, so page 1 down. Moving on to page 2. Here are a few powers, and I know this is very, very light, especially in this video, to see, but you can see this probably more clear on like the blank notes. But you want to try to have a good grasp on some of your powers. It's going to make a lot of things that we do easier if you can kind of just quickly, kind of like your multiplication facts. Things are just a whole lot easier if you kind of have a few of them already kind of at the top of your head, okay? So we're going to start evaluating exponential expressions, okay? So here's 5 to the third power, or 5 cubed, in other words, 5 times 5, 5. And these sorts of things you put in your calculator. Sometimes it's quicker just to do them. 5 times 5 is 25. 25 times 5 is 125. -5 times 3. So kind of look at these two guys here. They're similar, but they're different also, okay? So you've got a negative sign hanging out in the front, followed by 5 cubed. So it's negative, sorry, not negative, it's 5 times 5 times 5, kind of like what we just did. Well, that gave us 125, but you've got your negative in front, okay? So that is different than saying that we're cubing a -5. This cubed a 5 and made it negative. So that's kind of a kind of a common error or point of error in some problems for some students. Okay, so when you're cubing the full -5 because it's in parentheses, you're actually doing -5 times -5 times -5. So here's where it's going to help to remember your rules of your positives and your negatives that we talked about first day class. So -5 times -5 is positive 25. Positive 25 times -5 is where you will get -125. So it did work out that we had the same answer. Understand that's not always going to happen with the kind of, similarity you see here in these powers. So just be sure and understand the difference between cubing a -5 and then cubing it and then making it negative, okay? So understand that the base is the number or variable being repeatedly multiplied. So I mentioned it earlier, the 5 is the base. Well, that's a -5 base technically, but the base, again, is the kind of the bottom, the number that you're raising to a certain power. Okay, so in here, we're going to identify the exponent and the base, and we're going to simplify them if we can. So y is your base. Can you all see that? Yeah, y is your base, while 3 is your exponent. And there's nothing we can do to simplify y cubed. Since y is a variable, can't do anything about that, okay? So kind of be careful on ones like this. What exactly are we raising to a power is what we want to ask ourselves when we identify the base. Well, the only part of this that is being raised to the power is the x. So the x is your base, while the 8 is your exponent. Kind of keeps freezing. I hope it's not doing that during the video, but I guess maybe it is. What we want to know about 9 is we call that a coefficient. It's basically a number that's in front that we do multiply everything by, but in this case it's not part of the base because it's not being raised to the power, okay? However, looking in this third one here, since you've got the parentheses around it here, that entire thing that you see in parentheses is being raised to the third power. So that entire thing is your base, okay? So your base is -4z. And of course your exponent is the 3. I don't think that's too hard to figure out, okay? So we can actually simplify this one because we are repeatedly multiplying -4z. So -4z times -4z times -4z. Okay? -4 times -4 is positive 16. Positive 16 times -4 is -64. Z times z times z is z cubed. So that is how we would simplify that guy, okay? Last but not least, identifying a base and an exponent here. Your base, this is the second one, in that your base is just the z, okay? And your exponent is the 3. My z and my 3, they kind of look a little... Anyway, z and 3. All that you want to understand here, there's nothing really we can do to simplify it, is it's z times z times z. So the -4 is just a coefficient. Z times z times z is z cubed. So nothing to simplify. It looks the same as it did as long as you understand that the -4 is not being raised to the third power, okay? So base is z, exponent of 3. Up next, we are going to be looking at what we call the product rule for exponents. When you hear the word product, mention it, I think it was the first day, you want to think about multiplying. So anytime maybe there's a question you see somewhere that says, hey, find the product, or you read the word product, our brain wants to think, oh, there's some multiplication going on here, okay? So when you look at these guys and we're talking about exponents, you've got to have like bases, okay, for us to be able to multiply them together. And when we do multiply them together, we add the exponent. So you keep your base of 2. And I'll write it out so you can kind of see what we're doing. 2 cubed is 2 times 2 times 2, right? 3 times. 2 squared is 2 times 2. So when it's all written out, how many 2's do you see? Well, you see 5 of them. So this is 2 to the 5th power. We can do a similar thing for the x's here. X to the 4th is x times x times x times x. While x to the 5th is x times x times x times x times x. So altogether, when it's all said and done, I wrote up my 4x's and my 5x's. I've got a total of x to the 9th for my simplified multiplied answer, okay? So here's how your product rule is going to work. It's kind of what I was explaining at the beginning of working these, okay? You will use this rule when you're multiplying expressions. So when you multiply expressions with the same base. That's really important. You gotta have the same base, like the 2 or the x, okay? So you have the same base. You're gonna keep the base like we did. We kept our 2, we kept our x, and you're gonna add the exponents, just like we did, okay? So you kind of want to probably remember that so you're not trying to write all this out and count them all out. It's real short to just add them together and get your exponent, okay? So product rule, again, that's multiplication, and it's kind of summarized. This is a really small thing here, so I'll write it a little bigger. It's a times m, or I'm not a times n, a to the n power times a to the n power, and it's just explaining what I just explained to you. We've got the same base, and then you just add your exponents together to get the final exponent, okay? So that's exactly what we're going to do on these few down here, okay? So keeping your base, your like base. Understand if there's no printed exponent, like here there's a 1. So keep your base, 2 plus 1 is 3. Keep your base, 9 plus 6 is 15. Keep your base. Your base is C. Those coefficients do multiply together. So we've seen a little bit of that multiplication with the coefficients and the variables, but 3 times 7 is 21. Keep your base is C. Add your exponents, 4 and 5 is 9. Keep your base of negative k. You've got 8 plus 1 is 9. 9 plus 11 is 20. So that's what those guys will look like. Up next, we're going to talk about, I should say, power rules for exponents. Let me turn it where you can see it, okay? So this is kind of like a power to a power is what we're going to be dealing with here. So you've got 1 power and an additional power, okay? So something like this, 2 cubed, and we're squaring it. Well, we know what squaring something means, right? It's 2 cubed times 2 cubed. Well, we just had a little lesson about stuff similar to this. You keep those bases and you add those exponents. So 3 plus 3 is 6. Well, if we can remember all the rules, we can shortcut this as well and realize that when we have a power to a power, we just multiply 3 times 2 to get our 6. Okay, so we can cut this middle step out if we can remember that a power to a power, you're going to multiply, okay? So our power rule tells us when you raise a power to a power, to a power. In other words, an exponent to an exponent. You will keep the base like we've been doing, and you will multiply the exponents when you have a power to a power.